All right, man, I can't tell you how many times I've tried to make the second video. It's been brutal. So many technical problems, and then me not pressing record. I'm ensure I'm recording. All right, so I'm gonna give you a speed run here about everything I'm using and everything I've got, and just so you can see, I'm gonna start with the books. It's a stack, man. All right, did you see? That's the stack of books. I'll go through each one now. I just want to give a little bit of a backstory. Let me catch my breath here. I have an EET, Electronics Engineering Technology degree from a local community college, and it's great. It's a great degree. I got out of college and I went to work for an automation company. My actual title was junior controls engineer, but I started doing what's it called? Like being an automation electrical technician. Did that for about 3 years. And then I switched to hardware design, like electrical design for automation systems. And I do pneumatic design as well. I did that I still do that to this day. That's my profession. But I enrolled in university, Arizona State University, which is spectacular. You should go there if you want to do an online program. It's great. I honestly can't say anything bad about it. But for my specific circumstance, I already had a good job, making good money, and sinking the time and effort was taking away from me like living my life. And it wasn't going to return me anything more. Maybe more options in the future, but as far as like the pay scale, nothing. So I decided to not complete it. But now with AI, with ChatGPT and other programs, I'm like, I'm just going to learn quantum physics. I don't need a teacher. I had the greatest calculus teacher in high school. She was awesome. I can't lie. But, I can use ChatGPT to help me tell me where I go wrong and just help guide me and help build a curriculum but here's the books. So from my ASU days, I have this calculus book, which is all of calculus 1 through 3. It's a great book. And then I also have this differential equations book from my ASU days. Now on top of that, I've got some other these other books here. I kind of want to go in a specific order if I can. I bought a linear algebra book. I bought also a mathematical methods for the physical sciences or in the physical sciences. It has everything though. It runs back through calculus, linear algebra, differential equations. I think maybe even some statistics. Yeah, complex numbers. Oh, power series. And then I purchased Introduction to Classical Mechanics. Introduction to Electrodynamics. I also just kind of had no nonsense electrodynamics already. Who's next? Introduction to Quantum Mechanics. Condensed matter field theory. Introduction to Solid State Physics. Quantum field theory for the gifted amateur. and an introduction to quantum field theory. This one came damaged. I'm sending it back, and I purchased it's on its way, the hard copy. But that's everything. That's going to be all the books for the curriculum. It's going to be a long process, I think, but I think it'll be fruitful. Get back in some kind of order here. Maybe 5 years. 3 if I work really hard and fast. And 7 if I drag my feet. Could be never if I drag my feet. Right now I'm going back through the pre-calculus stuff to see where I fall short. And it ain't good factoring. There's been some rules I forgot. I went through and had ChatGPT make a curriculum, which I've shown you already, and then give me all my pre-calculus formulas, at least the best it could do. And then I've got some special factoring rules and patterns and stuff. It made that for me as well. And I'm going to use ChatGPT to my advantage here. This AI stuff is here to stay. And if we can use it to make ourselves better and faster, we definitely should. So if I don't have to remember something and I know I can always reference it on ChatGPT or at the very least the internet, I'm not trying to commit these things to memory. The end goal here is technology. And speaking of technology, here's the technology I'm using. So if you'll notice here, I'm using Krita. It's a drawing software, but it's wonderful. I've got it set up here to be like a notebook. Within here, you have layers. So I have a background layer, which is just white. And then I have grids turned on, so that I can draw graphs. And also, outside of that, I have here called diagnostics. This whole file is called calculus writings and documents. It's just going to be for the calculus book. This folder here is the diagnostics folder. It's the diagnostic section, which is what they're doing for a refresher math to gauge your abilities and what you might need to go revisit. And there's a section A, which is algebra. B is analytic geometry. C is functions. And is there a D? I don't know. Yeah, D is trigonometry. So I've got it split up by its functions, and then within the function I have the question. I was doing the questions all on a single sheet or layer, but so that I could copy them and get feedback from ChatGPT, but it's not enough space to work out a problem. Yeah, so here is how the layering's done. So I do question 5A on a single layer, and I can work out its question. Work it out here. I have more space. I'm also doing something here where I turn the layer a color, purple, and I'm using purple on the layer to point out something important. Right here. You see that purple? That's something important. Because I forgot that pretty sweet little mechanism right there. So just something I can come back to. Like a flag. On top of that, I have pins or brushes, they call them. So I have my group of brushes here under notes, and it's just a pin with, no matter the amount of pressure you apply, it's got the same basically size of tip here. It changes. It's a precision pin. The number 2 pencil, a marker, 2 different erasers, a circular one and a rectangular one. And then I have basically what I'm using is a highlighter. And you see how its layer is set to behind? I can go to a question here and I'm going to choose my highlight color and I can highlight behind it. If I didn't have behind on, I would color over it. See? So that behind is important for highlighting. Over here I have my color palette, and I've gone through and just set up these colors. This one for writing, this one for answers, that one for markup, green to mark something correct, that one for highlighting, this one for formulas. And then I have function 1, 2, and 3 for when I do graphs. I can have 3 separate functions on a graph and distinguish between them. And I think that's it. Yeah, this is a free open source software. You can even animate in it. I draw and make music. Got another company for that. So that's how I even was introduced to this software. But I repurposed it for note taking, like a virtual whiteboard. To write, I'm using a Wacom graphic tablet, and I can write on it while I'm looking at the screen. It's great. It's awesome. But I would go, if you're like getting into this, you don't want to spend too much money, you can do the XP Pen Pro. Deco V3, I believe. I have one at work. That's what I use, and that gets the job done. It's not as luxurious of an experience, but it's certainly you can do what you need to do with it. And then you may have noticed before I was using Obsidian, but had the divorce from Obsidian. I don't think I'd really use the whole mind mapping feature as much. No shade to anyone who does. Just didn't seem valuable to me. And you can't do like mathematical notation in Obsidian the way you can here in OneNote. So that's why I like OneNote. You see this formula here? Much more difficult to show. It wants to show it as like a programming formula, like how you would enter it for an ID in an IDE or for a programming language to interpret, and that's not good for mathematics. I mean, I like to be able to see that for when I do want to write programs in Python and such, but when I'm referencing formulas and equations, I want to see proper mathematical notation and symbology. So I switched to OneNote, put everything here in OneNote. And basically, I've got my notebook of quantum field theory, and I've got it broken down into phases. Phase 1 is my mathematical foundations. Phase 2 is classical physics. 3, core modern physics. 4 is condensed matter and materials physics. 5 is advanced field theory. And then I have a resources section. Is that everything? Oh, no. I'm also using Jupyter. I don't know much about it at this point. I just read that I should use it. Instead of like in school, you might use MATLAB, and there's an open source equivalent, GNU Octave. But from what I'm gathering, Python is the way to go these days. So this wraps Python programming in with like a notebook and text files and terminal access. So it just seemed like it would give me more bang for my buck over like GNU Octave or something. Is that everything? I think that's it. I think I've reintroduced everything. Am I missing something? No. Let's get back to it. Hope you're not planning to be like too entertained here, because the whole purpose of this is not to be entertaining. Just to document. You know, the same way at the end of a degree, you would have or the end of study in university, you'd have a degree as a testament to your studies and your abilities and such. I mean, I just want this to serve a similar purpose for me in the end. That way I can say, hey, I did that. And maybe someone can even come here and take inspiration, and they want to study and they want to go down a similar path. I'd love to hear if someone else does that. That would be awesome. Maybe we can do some work together. All right, question 3. All right, black writing. I've been writing the directions at the top of the page or the instruction. That way, if I copy and paste to ChatGPT to get feedback or to get an answer or something, it knows the intent. It's unfortunate, but if my calculus teacher could do it, I can do it. So find the center and radius of the circle. Find the center and radius of the circle with equation x squared plus y squared minus 6x plus 10y plus 9 is equal to 0. I'm not gonna act like I came into this and I was like killing it. I won't lie to you. I struggle with the factoring section. A lot of things I've forgotten. I mean, it's been 10 years since I've done almost any math outside of like Ohm's law and some very like specialized math for what I do at work. Not much factoring in that, so I've been struggling there. So we're going to get it though. We are going to get this. All right, so in our resources, we can go see the formula for a circle. Where is it? Formula for a circle. There we go. It looks like x minus h squared plus y minus k squared is equal to r squared. Now, I remember just from school that hk is the coordinates for the center point. So I need to make this look like that. Then I know my center point and I know my radius. Let's just move things around. X squared minus 6x plus y squared plus 10y is equal to negative 9. Oh no, that's not good. What's going to happen if I take the square root of that? I get an imaginary number. So I can distribute that back out. Let's just try to run through it here. Hold on, I want to zoom in a bit here. I guess working this plane right here. Okay, so what can I just pull out an X here and pull out a Y here? Is that a thing I can do? No, I don't think so. I think I'm not seeing this properly. Let's see. What if I pulled an X out and I can't just do that, can I? I don't remember the rules here. Let's try it. X, so X minus 6. I think I'm not looking at something properly. I'm not understanding. Can I set the X component equal and the Y component equal? Okay, let's try a different approach. Let's flip the negative here. Set that equal to 9. We'll take the square root of everything. Okay, let me see. Negative x plus 6x is equal to 9. Ah, I just had an idea. Actually, we won't do what we did here. It's minus or plus 9 is equal to 0. What we're going to do is we're going to split this 9 into... Got it. Got it. Do I got it? Can I split it into 2 perfect squares? And still bring 1 over here? I think I can make this happen. What would a perfect square be here? How could I make a perfect square out of both of these? So it would be x. So x minus something squared. So it will be negative 3 and negative 3 here. 5 and 5 here. Okay. So if I needed negative 3 over here, that would become 12. X squared minus 6x minus... Nope. What's negative 3 times negative 3? Plus 9 plus y squared plus 10y plus 25 is equal to 25. Then I can factor these. And then this will be x minus 3 squared plus y plus 5 squared is equal to 5 squared. Is that it? The center is 3, negative 5. And the radius is 5. Let's look. That's question 3. Center is 3, negative 5. Radius is 5. We got it, boys and girls. All right. That was an easy one, actually. Started off rough. Started off scared. Won't lie. Now this, question 4, has 6 parts. Jeez. Let's get it set up. I believe in being organized. That's part of the engineer. They call me an engineer. I don't. I reserve that title for pretty much professional engineers, people with a PE. Everybody else is some form of a designer or like a very technical designer or some sort of technician. But you know, can't control what the industry calls me. All right. So 4A, and then I'm going to write the instructions on this one and copy and paste. So let A negative 7, 4, and B, so these are points, 5, negative 12, be points in the plane. Points in the plane. Okay. Now we're going to copy this and paste it 5 more times. Then we're going to call this one 4B, 4C, 4D, 4E, once more, and 4F. All right, now they got their own instructions. It says find the slope of the line that contains A and B. Find the slope of the line that contains A and B. All right, the slope of the line that contains A and B. It's easy. I'll tell you what we're going to do, though. We're going to calculate it, and we're going to graph it. Calculated slope of a line, point slope form will be point slope form is x2 minus x1 over, so m, what is it? Point slope form, y minus y1 is equal to m times x minus x1. Or we can find simply the slope by setting y2 minus y1 over x2 minus x1. Pretty obvious. So m is equal to negative 12 minus 4 over 5 minus negative 7, so plus 7. M is equal to negative 16 over 12, which is 4 over 3. M is equal to negative 4 over 3. So we drop 4, go over 3. Drop 4 over 3. Let's run it. Let's test one. We're going to draw our axes. 1, 2, 3, 4. 1, 2, 3, 4. Let's go up one more. And then 1, 2, 3, 4, 5. All right. So let's draw the line. Negative 7, 4. 1, 2, 3, 4, 5, 6, 7. Oh, and then up 4. Negative 7, 4. 5, 12. 5, negative 12. 1, 2, 3, 4, 5. And then 4, 8, 12. Right? And for good measure, we'll just connect them. So, rise over run. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Yep. Technically, I should have started here. So we go over 4. 1, 2, 3. No, over 3. No, let's drop 4. 1, 2, 3, 4. Over 3. 1, 2, 3. That's it. All right. Let's see. What would the next question be? Find an equation that passes through. Find an equation of the line that passes through A and B. What are the intercepts? The intercepts? Well, the x-intercept is. So the question is, do I go to B and solve this? Tell you what. Let's just copy this. No, I don't want to take a screenshot. Let's copy this bad boy. Then we'll come here. We'll paste it. Go back to our brush. So we know that m is equal to negative 4 over 3. Let's write out the rest of our instructions. I don't want to scratch my pad with the button here. Find an equation of the line that passes through A and B. What are the intercepts? Find equation of line through A and B. What are intercepts? All right. I mean, the x-intercept is what? -4. And the y-intercept is what? -5? I bet I could calculate that too. All right, the equation then, point slope form, or y is equal to mx plus b. Actually, it's pretty simple. Y is equal to -4/3 plus negative or -5. X -5. All right, that one was really easy. Find the midpoint of the line segment AB. We are going to copy this yet again. And each time we're going to bring something with us. Let's bring this with us. What? Oh, yeah. Let's bring that down here. And let's also get rid of that. We don't need that. We know the slope now. Find the midpoint of the segment AB. Find the midpoint of AB. Well, I'll tell you the midpoint formula. It's pretty simple. It is x1 plus x2 over 2, y1 plus y2 over 2. Or you could use the distance formula and divide by 2. But why? We have 2 points. And an incredibly simple, it's the same thing. So, x1 plus x2. So it's -7 plus 5 over 2. And then 4 plus -4, which is, plus 12, plus -12, which is -12 over 2. So that gives us -2 over 2, which is -1, and -8 over 2, which is -4. And we can check it here by just looking. So -1, -4, -1, -4. How many? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then 8. 8. All right. That's clearly the... Is that the final answer? Yep, that's it. All right. 4D. Find the length of the line segment. Okay. Let's go up here and let's steal this. Paste that into here. All right, let's get our eraser out. All right. So here, find the length of the line segment AB. I don't know why sometimes I choose to shorten the instructions and sometimes not. The distance formula is, let's write it over here. So if we copy later, the square root of x2 minus x1 squared plus y2 minus y1 squared. So D is equal to x2 5 minus, so 5 plus 7 squared plus y2 x y negative 12 minus 4 squared. The whole squaring square roots, that's just a clean way to get rid of negatives. Or square rooting a square. It's beautiful. It's kind of cheating. 12 squared, 144. So the square root of 144 negative 12, so negative 16. Geez, what's oh, the calculators I got a TI-84 plus CE color edition, rechargeable. Come a long way since I was a kid. I'll show you. I still got the one back here I used in high school. One of these old school. Yeah. Dang. Crazy. I also have a TI Inspire CX. It's a great calculator. Do integrals and I think it can calculate derivatives. But you can plug in functions in that thing and it'll solve them. That's awesome. It's a great calculator. I want to say I used a TI Inspire in calculus. I want to say my friend had an 89 though. I don't remember. Yeah, I think it was an Inspire in calculus. All right, 16 squared. I think it's 256, but yeah, 256 plus 256. 144 plus 256. 260 plus 4,300, 400. D is equal to square root of 400. Let me just check my math there. 144 plus 256. Yeah. And the square root of 400 is 20. So it's 20 units in length. Who's next? 4D. Find the length. Oh, 4E's next. Find an equation of the perpendicular bisector of AB. Got you. Find an equation of the perpendicular bisector of AB. I could do some fancy stuff here, but I don't think I should. I think I should work off that midpoint and do the opposite. All right. So let's do some copying. And let's erase this. So if I come off of here and I go 1, 2, So what? I got to go the opposite direction. So I need positive 4, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Right. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Right, that would be the perpendicular bisector. It cuts that line in half, and it's exactly perpendicular. It'd be 90 degrees, 90 degrees. Right? Or am I losing it? Would it have to tilt more? I think I might be wrong. I think it should look more like this. It should come up to here. Okay, we'll see. Just visually, it looks strange. So, find the perpendicular bisector of AB. What time is it? Not bad. Not bad. Might be doing some analytic geometry tomorrow too, though. All right. It would have a different x-intercept. How do you just find a perpendicular bisector? I want to say we could do it like this. We could say y is equal to this midpoint. What was that midpoint? It's negative 1, 1, 2, 3, 4, negative 4. So we could go y plus 4 is equal to m. We're going to leave that blank. Our slope, because our slope would basically have to go, it would have to have the opposite direction. Not a different magnitude, an opposite direction. So of x minus x1, so plus 1. And then it would be 4 over 3. Right? So that would work out y plus 4 is equal to 4 over 3. X plus 4 over 3. Then we would subtract 4. So y is equal to 4 over 3x. 4, 3 is a fraction. Base 3 would be 12 over 3. So what is 4 over 3 minus 12 over 3? It'd be minus 8 over 3. So is that 2 and 2/3 on our intercept? I think so. 1, 2, 2 and 2/3. Looking good. Looking good. Let's check some points here. If x was negative 4, what would y be? Would y be negative 8? Let's check it. So y is equal to 4 over 3 times negative 4 minus 8 over 3. 16. So y is equal to negative 16 over 3 minus 8 over 3. 16, 24 over 3. Y is equal to negative 24 over 3. Y is equal to negative 8. We got our answer. That's it. That's our equation. All right. What do we got for 4F? Find an equation of the circle for which AB is a diameter. Beautiful. Using algebraic logic to represent geometrical form and structure is I mean, it's peak math, man. It's peak precalculus. It really is. It's beautiful. Math is beautiful. It's so beautiful, in fact, that we can represent the fundamental physical model of the universe with it. Like, hands down, most beautiful language out. I like to write poetry, but I gotta say that I, I've been speaking English my entire life. So since I'm kind of creative, poetry kind of comes semi naturally. It's much easier. Once I speak this fluidly, I can't wait to see what kind of poetry I'll write. Mathematical poetry. That's what I'm going to start calling it. When I publish some sort of math, if I ever do, I won't call it a proof or whatever. I'll call it a mathematical poem. Be great. Ah, okay. Back to business. All right. Find an equation of the circle for which AB is the diameter, or a diameter. Yeah, whatever. The diameter, a diameter. Tell you what I want to do. I want to take this. Ugh, what did I do that for? All right. Let's clean this up a bit. I mean, this is the downside of if it was vector software, I would have an infinite plane here. And I could have done that for something like Blender or Inkscape. Nah, it's okay. This is a raster software, so it literally renders pixels rather than uses a mathematical formula to generate a rendering based on your level of zoom and where you're at on a canvas. So I wanted that one. What's the distance? Where's that one at? Let's take the distance is equal to 20. Get that in our view. Is that all I might need? What else? What other did I answer? Find equation of the line that passes through. What are the intercepts? Yeah. Slope of the line, midpoint. Yeah, let's get that midpoint. Midpoint. Keep wanting to take a screenshot. All right. Let's put that midpoint down here. Actually, let's put it there. Shrink this bad boy. Put it right there. All right. So. Oh no. What did I do? Let's shrink it here. Let's turn that on. This is a beautiful thing. This little thing right here only allows you to draw where you've already drawn. So b. See what I'm going to do here? I'm going to darken this because, you know, I shrunk it. So that made it, why is that not working? It should be darkening. Am I an idiot? It's highly possible that I'm an idiot. Oh, there's physically no pixels too. Okay. Oh well, we're not going to burn a bunch of time on it. Let's just move it. I'm going to move it to here. We get the point. Worst case, we can just look at it. He said, would you look at that? All right. So I want the equation for a circle. That's the distance. That's the midpoint. So if that's the midpoint and we know the form, it's x minus h, so plus 1 squared plus y minus k, so plus 4 squared is equal to the radius squared. So 10 squared. So the distance is 20. Divide that by 2. You get the radius, which is 10. And then you square that. So that should be our formula. Let's check all our answers. All right, for A, we've got, what we got here? Negative 4 over 3. For A, negative 4 over 3. For B, it is it's shown in a different form here. X-intercept's negative 4, Y-intercept is negative 16 over 3. Oh, that makes sense. I'm an idiot. But shouldn't B be the Y-intercept? Okay, let's get in here. Let's see what we did wrong here. Because now I think I got everything wrong after this. Or maybe I just got this one wrong and I got lucky. So they're saying that the answer here is 4. Oh, what's going on? 4x plus 3y plus 16 is equal to 0. And the y-intercept is negative 16 over 3. How the hell did I do that? There I found the slope. So the slope's right. What do I do here? Let's work it down here. I guess I've got to put this, the equation, I guess there's no better thing for me to do than put it in point slope form. Yeah, to check it. I got eager. I thought I knew what I was doing there. I thought I just looked at that and I made a mistake. But there's no way to just know that that's 16 negative. There's no way to know that that's 5 1/3. Negative 5 1/3. Just looking. I mean, obviously I could tell right here, but after seeing it. So let's put this bad boy in point slope form. So y minus y1. So y minus 4 is equal to negative 4 over 3 times x minus x1, so plus 7. So y minus 4 is equal to negative 4 over 3x minus 28 over 3. So y is equal to, so we add 4, which is 12 over 3, which would make that negative 40, no, which would make that 16 over 3, negative 4 thirds x plus, no, minus 16 over 3. Dang, how am I skewing that bad? Which is obviously, if I multiply both sides by 3, we get 3y minus is equal to a negative 4x minus 16. So add. 3y plus 4x plus 16 is equal to 0. Got it. And then obviously we see here my y-intercept would be negative 16 over 3. Yep. Okay. Let's see what I did wrong. I was just being an idiot, not paying attention. All right. So our answer here is what? Negative 1, negative 4. Negative 1, negative 4. 4D. D is 20. Correct. He said that is correct. Billy Madison. 4E. Where's my answer? Perpendicular bisector. But now they're going to represent it in that other form. So let me do it in that form really quick. Times 3. So 3. That would be 3y is equal to 4x minus 8. Bring it all over. 3y minus 4x plus 8 is equal to 0. What? How are they? And then that's wrong. How did I come so close? So it says the correct answer is 3x minus 4y is equal to 13. What the hell? What did I do wrong here? Yeah, let me erase something and work it over here. Yeah, what am I missing here? So it's y minus, so x is negative 1, so plus 1. Oh, I inverted my damn, what an idiot. Man, I can't afford to make mistakes like this. So it's x plus 4. There we go. So y minus 1, which is 3 over 3, 13 over 3. So 4 thirds x plus 13 over 3. Y, so 3y is equal to 4x plus 13. Then we got, if I put it in their form, 3y minus 4x is equal to 13. I wonder why they're showing it in all these weird ways when they didn't ask for it like that. That's standard form. Oh, okay. So I need to show my. They didn't ask for standard form, to be fair. I guess you should show it in standard form. Okay, let me understand something here. What does standard form gain me? I just want to see. I mean, why would I represent something in standard form? What can I deduce from that? What's the benefit of representing a line in standard form? Camera died. Okay, it says standard form is useful. Algebraic structure and system. Standard form is especially useful in algebra, linear algebra optimization, and physics. Easy to represent linear constraints. In real systems, equations naturally appear as balances or constraints. Example, 2x plus 3y is equal to 6. This can mean conservation laws. Yeah, just tell me why. Better for solving systems. Systems become structurally clean. Oh, I guess it's cool. I could just add, yeah. This aligns with elimination, matrices, Gaussian elimination, integer coefficients. Instead of y is equal to mx plus b, or negative 2/3 x plus 2, you can write 2x plus 3 is equal to 6. This is cleaner for symbolic manipulation. That is cleaner. Reveals the normal vector. Ah, the major deeper reason. For ax plus by is equal to c, the vector ab is perpendicular or normal to the line 2x. So the vector 2, 3 is perpendicular. So if I go over 2, up 3? Maybe I'm misunderstanding. 2x plus 3y is equal to 6 has normal vector 2, 3. Okay, I have a feeling I'm going to have to remember that. Standard form extends directly. Generalizes naturally to higher dimensions. Oh, I see. You just add the coefficient plus the other dimension. Nice. Closely connected to matrix theory. Okay, so what I'm gathering is there's a plethora it says modern mathematics and physics overwhelmingly favor implicit forms like the function of x, y, z is equal to 0, rather than explicit forms of y is equal to f of x. That makes sense. Because implicit forms generalize much more naturally to complex systems, standard form is your first exposure to that viewpoint. All right, I got it. All right, last one here, 4f. I have x plus 1 squared plus y plus 4 squared is equal to 10 squared, which is 100. So we'll just write that. X plus 1 squared plus y plus 4 squared is equal to 100. So we're done. That's it. It's question 4. And I think I might call it. Looks like I might go for a walk, do some reading. All right. Let's get back to it. All right, 5a. I kind of want to have it right here. Sketch the region in the xy plane defined by the equation or inequalities. Okay. Negative 1 is less than or equal to y, which is less than or equal to 3. So it's all of x from negative 1 to 3y. Hmm. Y is -1 to 3. I kind of want that to be no outline. Can I not make that? Hmm. Oh yeah, the opacity's here. So -1, 2, 1, 2, 3. That's the region. And we should go a little bit darker. There we go. I'm trying not to be gulping down y'all's ear. Sketch the region in the XY plane. Okay. Positive X below 4. So what would that be? So X is less than 4. 1, 2, 3, 4. So that's a point right there. Four. Man, I'm gonna try to listen to the new Drake album in the damn headphones, but I can't. I want to hear it, and I can't focus on the on the math. Okay, so it's gonna be between two values. So whatever is less than 4 that I fill in here. So if I put in 4, but you use a dotted line. Oh, so earlier I should have, when I did that rectangle, I should have done a brush outline. Let's go back and correct that really quick. The opacity down. Yeah, because you got a solid line around it. All right. All right, back here. Then here we do no outline, and I'll just draw it. So it would look like -4 and 4, because if I plug in 3 there, 3 is less than 4. 4 is the boundary. 5 is obviously greater than 4, and then in the other direction, -5. So it's 4 to 4. And then the y will be -2 to 2. So it'll be something like that. So this should look like this. And if oh yeah, I just got the background color set up. So it'll be something like that. Sync. All right. Y is less than 1 minus 1 half x. Let me rewrite this. 1. Man, I really wish that I could. You know what I'm going to do really quick? Hold on. Sorry. Let's go to all. I need a shape brush. I can use a shape brush here to hold on, I have to do something. Technical problem I've got to check. I want to listen. Hello? Okay, great. To make sure the audio is performing properly. All right, so I want to add a shape brush here into my thing, and a shape is, I'll show you in a second. Where is the shape brush? No. Where are they? Tell you what. Let's go to the essentials. For digital. There it is. I believe that's it. Shapes fill. We're going to take that, right click on it. Assign to notes. Go back to our notes. That lets me do things like this. And could have swore that I had a shortcut to swap the background and foreground. Where's that under? Brushes. No. Tool shortcuts. Oh, we'll swap X. That's it. So now I can go between black and gray. Sweet. All right, let's turn the opacity down on this brush, because that'll be good. All right, now. All right, y is equal to negative 1 half x plus 1. So the y-intercept is 1. Maybe later. Y-intercept is 1. Negative 1 half is our slope. So we go down 1 over 2. Down 1 over 2. Down 1 over 2. Oy. 1 over 2. All right, so that's it. And its y is less than. So I'm assuming it's everything below there. So let's plug in 1, 2, 3, 4, 5, 20. So 20, so it'd be 20 times 1 half is 10. Negative 10 plus 1, negative 9. So at 20, we're at negative 9. Wait. doesn't make any sense. Yeah, let me back up. When x is 0 plus 1, y is 1. Yeah, x is 0, y is 1. Okay, then when x is 2, what is 0? X is 1, 2, 0. Yeah. So is why is it when I plug in, oh, negative 20, I'm an idiot. When I plug in 20, I'm negative 9. Here we go. 20. Negative 9. And then over here, when I'm negative 20, 11, 8, 9, 10, 11. Great. So we want to go from there to there. That's what our line's looking like. So what region would we fill here? Would we be below this line or above this line? I mean, that's the line, so there's kind of a region. It says sketch the region. I'm going to just say we're going to go below it. I'm going to show you the magic of this pin here. We can do like this. And you got to bear with me though, because it's not the greatest. That's good enough. We get the gist. But we drew this line here, and since we're just a less than, it needs to be dotted. I know it's not perfect, but it's good enough. Right? That's it. I think. Pretty sure it is. We're less than the line. All right. Y is greater than or equal to x squared minus 1. Shit. All right. When x is 0, we're negative 1. When x is 2, we're 3. 1, 2, 1, 2, 3. When x is 4, no, when x is 4, 15. 1, 2, 3, 4. Damn. 1, 4, 8, 12, 15. Right, and then obviously when we're negative, we're just in the opposite direction here, so. I mean, this software is cool. Watch what I can do. I can go here. Here. And here. Actually, I'll show you something even cooler. We can come here. We can establish the Y mirror. And then what I can do is I can draw one here. And then I can pull this out. Like that. Hit enter. I drew it on both sides. It's not the cleanest. Nah. Let's do a couple of in-betweens. Because I want to go what's 3? 9, 8. So 1, 2, 3, 8. We're there. Let's do 1. 1 squared minus 1 is 0. So we're here. So now if we draw our line, it's going to look something like this. Right? Something like that. And we're going to be inside of it. It's going to look like this. Ah, okay. Something like that. Maybe, possibly, hopefully. All right, this one says x squared plus y squared is less than 4. This is looking circly. It's looking kind of circly. Or ellipse. But if I had to guess, no, this is a circle. It's got its center at 0 and a radius of 2. So, yeah, here, we're just going to plop a circle down on this bad boy. Right? So we got a center at 0, which is 0, 0, 2 squared. 1, 2. Yeah, that's it. All right, let's just kind of make it a bit dotted. And we'll kind of fill it in. So that's how that'll look. Oh, this one's a circle too. Is it? I don't know. That one's looking. That one's kind of looking like an. I keep saying, keep going with this whole ellipse thing. It's kind of looking ellipsy. No, that one's certainly an ellipse. Yeah. If I divide by 144, what's 9 over 144? 0.0625, which is what, 1 over 8? No. 1 over 16? Yeah. So this becomes 1 over 16x squared. Or x over 16 squared. No, x squared over 16. 16 9. Y squared over 9 is equal to 1. Right? That's the form of an ellipse. Yeah. So then we've got A is our, I forget, they have some term, I can't remember. You have your, basically you got a big radius and a small radius. It's the lengths of the ellipse in each direction. So in the x direction, it's going to be 4 and negative 4. Right? Because this is a squared. And then this is b squared. So this would be 4 and 3. Sorry. And 3. Right, so we're equal to here, so it's everything in there. Ugh, gosh, that's terrible. So that, do we fill it in? No, I don't think we do. All right. Now, let's see. That's correct. I shouldn't have closed the sides in here, but I'm going to chalk it up to the software. That is correct. That is correct. He said, that is correct. That's correct. This, correct again, buddy. Correct. 3 and 4. Yep, got it. Dang, that was easy, man. These analytic geometry ones are much easier than the factoring. All right, who's next? God dang. Let's move on. Look, now we're going to functions. So now we're going to be in section C. Section C. What do we got? Question 1. And then we've got 1A through E. 1E. Let's write the... It says the graph of a function f is given at the left. Man, you guys won't be able to see this, and I've got to constantly look over here now. So A, let's copy this a bunch. D, C, B, A. 1A, 1B, 1C, C. All right, so 1A says state the value of f negative 1. State the value of the function at negative 1. Negative 2. It's giving me a graph, and it looks something like this. Right? I wish I could... I'm going to think better about this, because I need a method where I can have video on the book as well. I'm going to have to work on that. I'm going to think about that. Okay. Question 1B says estimate the value of f2. Estimate... Oh, hold on. Let me do something here, because I already know what it's going to be looking for. It's going to want it in a proper form. Estimate the value of f function at 2. And here I'll just kind of draw out the function for you guys. All right, what does it do? It starts at pretty much negative 3, 2. So it starts kind of right there. Then it dips down to negative 1, 2. And it loops back up right around 1, 2. Somewhere in there. And then it kind of ends at 1, 2, 3, 1, 2, 3, 3, 3. there. So it kind of does a thing kind of like this. That's the graph. That's what I'm looking at here. All right. Estimate the value of F2. It's approximately I don't know, 2.7, 2.75. So f of 2 is approximately 2.75. All right. Let's steal this. Control C. Control V. All right. So 1C says, for what values of x is f of x equal to 2? For what values of x is f of x equal to 2? So x equals 1. So 1 and -3. Right? 1, 2, 3. So we're at 2. 1. We're at 2. It's kind of parabolic. All right. That's the one downside. It's copying and pasting when you don't remember that you need to do it. Hold on 1 second. Let me just run through there. Go to here and do it. All right. 1D. Estimate the values of x such that f of x is equal to 0. Okay, where does it look like y is equal to 0? Negative 0.75? That's what it looks like to me. Right? See right there? I know y'all can't see, but because it's so small, but 1E, state the domain and range of f. State the domain and range of f. I kind of don't remember. I think we would use the same formulation. Sorry, they got that little fancy f. All right. Huh. That's kind of a tricky one because it's state the domain and range of f. All right. I hate that I keep leaning away to look at the book from the microphone. It'd be nice if I could bring it with me. I mean, I guess I can. I guess I can control the mic better. So it appears that the domain, which is the x, all possible x values, it's about 1 to -3 to 3. So the domain is -3 to 3. And the range is -2 to 3. That's what it looks like to me. Okay, let's check them. All right, 1A. -2. It's correct. That's it. That's correct. 1b 2.8. That's good enough. I wouldn't fault me. Would you fault me? C -3 1. Yeah, that's correct. D. Okay. How did I get this so wrong? It says -2.5.3. Ah, x is 0. Damn it. It's where x is 0, not y is 0. How did I mess that up? Yeah, I messed that way up, bro. That's... -2.5 and 3. Obviously, if we look at -2.5 and 0.3. Okay. Okay. All right. My fault. My fault. All right. And E. -3 to 3. -2 to 3. We got that one right. Oh, maybe I should turn all the ones I got right blue over here and all the ones I got wrong red. Not important here. Might be important later. Okay, that's it for question 1. Let's move to question 2. It's only a single question on 2. Question 2. If f of x is equal to x raised to the third, x to the third, so if f of x is equal to x to the third, evaluate the difference quotient. Oh man, they're talking some stuff I don't remember. Evaluate the difference quotient f of 2 minus h minus f of 2 over h and simplify. Oh, maybe I can do this. All right, let's just give it a go. So for 2 minus h is equal to x to the third minus 2 so what, we'll end up with negative x to the third minus 2 is equal to h. And then we can plug 2 in, x to the third, 2 to the third is equal to 8. So now what, we can fill in, we know h I did something wrong here. I'm sure of it. Here, let's just see. 2 minus negative x to the third minus 2 over negative x to the third minus 2 up here minus 8. That's crazy. Hmm. Plug it in with this one. All right. All right, let's do some distributing here to make things look a little simpler. Let's move this over here. So we've got 2 minus negative x cubed plus 2 minus 8 over negative x cubed plus 2. Then that means we've got 2 plus x cubed minus 2 minus 8. They cancel out, so let's just finish this. Negative x cubed plus 2. Come back up here. So we're going to have x cubed minus 8 over negative x cubed plus 2. Is that it? I don't know. Up top, it's looking like I can do. I think that's it. Let me look. What was this? Question 2? Oh, God, I got it so wrong. They're using H's. All right, let's start over. This one, I can't even. I won't even redline it. It's so badly wrong that I have to just reevaluate it. They're using H's. Jesus. What am I doing? What's going on here? F of x is equal to x to the third Then what would f of 2 be? 8? Yeah. What's going on here? I don't understand. Where the hell's the h come from? Hmm. Okay, hold on. Might be onto something here. F of 2h, so I can plug 2h in here in f of 2x. So what is 2 minus h cubed? Oh, I think I got it. Man, I'm so tempted to just... I need to work on my factoring. But man, you don't know how tempting it is to just come down here. Say 2 minus x raised to the third. Can't do it. That would look like negative 1 times h minus 2 times h minus 2 times h minus 2, which would be negative 1 times h squared minus 4h plus 4 times h minus 2. All right. Negative 1. What kind of 1 is that? Negative 1 times h to the third minus 4h squared plus 4h minus 2h squared plus 8h minus 8. Let's simplify that. H to the third minus 6h squared plus 12h minus 8 Let's put the negative back into this whole thing. Negative h to the third. Though. In the answer, it's all positive. So I don't get. Okay. Then I can put that all back in up here. Negative h to the third plus 6h minus 12h. And then plus 8, which is plus 16 over h. Still don't get it. I'm close, though. I see that I'm close. Maybe I should have worked it in this form and not tried to convert it to this form. Maybe I made a mistake and missed a step there. Because their answer is h squared plus 6h plus 12. Which I would get if I could cancel that out. And that. Yeah. All right, we're going to redo this. Because I must have made a mistake in my conversion here. Let's just do 2 minus h times 2 minus h times 2 minus h. Right, I can plug 2 minus h into there, and it's just 2 minus h cubed. So we're going to have 4 minus 2h minus 2h what's negative h times negative h? Plus h squared? Yeah. Yeah, that's it. Times 2 minus h. So we've got 8 minus 4h minus 4h plus 2h squared. And then we've got minus 4h plus 2h squared plus 2h squared. What's negative h times h squared? I don't know if it's negative h squared or negative h cubed or negative. Oh, this is where the calculator comes in. Instead of h's, I got to use x's. Negative x times x squared. It's a negative x squared. So if it's 2, negative 2 times 4 times negative 2, negative 4. Okay, that's all right. I guess it doesn't really matter because it's going to be negative in the end. I'm kind of wasting my breath there. Minus h cubed. All right, let's clean it up. 8. How many minus 4h's? 1, 2, 3. So minus 12h. Now I see why they're showing it backwards from what I would imagine. Interesting. Okay. How many 2h squareds? Plus 6h squared. All right. Minus h cubed. Okay, and then if we put the other stuff in, minus 8 over h, then these 8's cancel. So we get negative 12h plus 6h squared minus h cubed over h, which gives us negative 12 plus 6h minus h squared. Huh. That doesn't make any damn sense because they've got the opposite. 12 plus 6h plus h squared. So, somewhere along the way here, I've made a sign error. Where did that happen? Oh, I see. I see where I did it. Let's back up. See exactly where I made it happen. H, negative h times negative h is not plus h squared. It is actually minus h squared because you're squaring the negative factor. And that's where it all happened. It's exactly where it happened. Now, if I factor it, I'll get the right answer. 8 minus, let's clean this up a bit. Let's get rid of the, so 4 minus 4h minus h squared. All right, times 2 minus h. So 8 minus 8h minus 2h squared minus 4h plus 4h squared minus h to the third. No, plus h to the third. So 8 minus 12h minus 2h squared. How is this one confusing me so damn much? Ah, see what I did wrong. This should have been, this should be, no, I don't get it. I don't get how to work this one out properly. What am I doing wrong here? This makes no damn sense to me. Because on one hand, how could I not pull out a negative 1 cubed here and then converted that to h plus 2 or h minus 2? And then worked it. I really don't get this. What am I doing? Minus 12h. So write 2h squared. Negative 2h squared would have been negative 6h squared plus 12h. I just don't get how everything's positive in the correct answer. Hmm. 4 minus 4h minus h squared times 2 minus h. So work that out here. Let's just continue here. 8 minus 12h minus 2h squared plus h to the third. So in this one, okay, I'll tell you what. We're going to have ChatGPT take a look because I'm going to need a teacher's help on this one. Okay. Oh. Oh, I think I see. Compute each function value. F of x is equal to x cubed. We have f of 2 minus h, which is 2 minus h cubed. Yeah. And 2 to the third, which is 8. So 2 minus h cubed over 8 over h. So the correct expansion of 2 minus h cubed is h minus 12h plus 6h squared. 8 minus 12h plus 6h squared minus h to the third. I got that. Okay, I did the correct expansion over there. Okay, so if I subtracted negative 8 here, like it's saying, over h, that would give me negative the book's wrong. The book is wrong. So I just thought I was wrong. I would have gotten it because it would be negative h to the third plus, no, negative h squared plus 6 minus 12. No. Oh, this is squared. Plus 6h minus 12. Which written in their way is negative 12 plus 6h minus h to the third. So the book is wrong. The book I am using Boy, I'm done for the day. It says that means the book is almost certainly using f of 2 plus h minus f of 2 over h instead of f of 2 minus h minus f of 2 over h. And then I look down at the question and I'll be damned. F of 2 plus h minus f of 2 over h. I wrote it wrong here. We're done for the evening. We're done. We're done because I'm done. Jeez. What a mistake. What a waste of my time. I burnt so much time. Oh well.